Hi, welcome to Weather and Forecasting. This is Module 10, and we're going to begin by talking about the lightning part of the lightning, thunder, and tornadoes chapter. This chapter is going to be a long one. There's going to be a lot of videos, so let's start diving in because there's a lot of content. We're going to really recycle all the information we've been talking about and learning, and the one that's going to introduce you to some new information that's not going to be so repetitive is the first thing I'm about to cover, and that is lightning and thunder. So lightning itself is often taking place within the clouds, and it's actually an electrical discharge. It is electrons jumping, and it's doing it at incredible amounts of energy release. And when that energy release occurs to try to create magnetic balance between ionically charged negative particles and positive particles, it's releasing both light and heat and sound energy along with electricity itself. There's also research that was done back in 2012 where we discovered that there's also plasma that shoots off from the top of the cloud itself when there is lightning strikes that occur. So there's also plasma formation. So there's a lot of activity and energy that takes place when lightning strikes. With that said, most lightning happens within the cloud, so it's cloud to cloud, which means it's striking up inside of the cloud itself or from one cloud to the cloud next door. And this is about 80% of all lightning strikes. There is about 20% of lightning strikes that will actually take place where it goes down to the ground. So it's not as common, but it does happen. And within any one thunderstorm, I can expect a few strikes to the ground, with most strikes happening within the cloud itself. The reason why I get an actual lightning strike to occur is because I have charge separation occurring with the cloud. And this happens in cold clouds. So going back to our ice crystal process, when I formulate ice crystals, the ice crystals that are happening where there's super cool water droplets and ice crystals and ice crystal nuclei. The ice crystals are in their solid forms, which means they're able to keep that steady state of being unbalanced. And some of them have a little extra too many electrons, making them a negative charge. And some of them have too few electrons, making them a positive charge. The ones that have too few electrons have less density than those that have one too many electrons. And so there's a natural separation of charges where the negative charges, which are a little bit heavier, stay along the base part and the positive charges will float up top. And so I get this natural separation. With that said, on the surface of the Earth itself, we all have a natural ionic activity occurring, and all our positives tend to hang out at the top too. So even us ourselves have what's called positive streamers that will reach up towards negative actions or negative electron particles. And so here's some of this example of what I'm talking about. So we can see some negative activity and some positive activity. And this is called the charge separation occurring within my ice crystal processes. What happens is the electrons attempt to find a path, and they'll attempt to find a path in many directions. So there's lots of branching that'll happen because it'll try to go this way and then it'll reach back up and say, nope, that didn't work. And it'll try to go this way and come back up and keep going. So it keeps going up and down trying to find a path. And eventually it'll make a connection to what's called a positive streamer. A positive streamer is the positive ions reaching up towards the negative step leader that's coming down to find its positive streamer. When I make a connection with a positive streamer, that's when I get a stroke, a lightning stroke. And that's where I'll see the discharge. And the discharge is when I actually have the release of electricity that will move down this line or connection that I've made. So some of those terms are written right here. So that gives you, and when I finally make that connection, that's when I get my flash. That's when I release my light. And I'll also get thunder, which is the sound release caused by the rapid heating. So all that heat that's released with the electricity that's going to shoot down causes the air around it to actually heat up and it gets up to like 30,000 degrees Celsius. So it's incredible amounts of heat, and the air will move away because it's so hot. It moves far and fast, and then it gets cold really rapidly, and it snaps back, and it actually breaks the sound barrier. So that's where I'm getting my thunder. And this all happens at the exact same moment where I get my discharge. As far as global distribution of lightning, you can see the locations where lightning strikes are happening daily in red, and where they're less common. And some of these blue, dark purple areas, it's not necessarily that they're uncommon. It's also just because we don't have research on it, but they're not as common in the poles, obviously. They're very common in tropical regions and in tropical low pressure centers, so places where I will form thunderstorms daily. And in some place like Florida, especially along the western coast on the Gulf of Mexico, here, I will actually form a thunderstorm in the summer months pretty much every afternoon. I will get a nice vertical cloud that will form, and that vertical cloud has a charge separation that will occur, and that charge separation will create a nice thunderstorm with lightning that will happen daily, every afternoon. As far as what clouds can make lightning, it's very specific. It is thunderstorm clouds, which are cumulus-nimbus clouds, vertical clouds. It has to be that vertical cloud to get a good charge separation. Otherwise, I won't get enough charge separation to create step leadering, which will cause an actual lightning stroke, right? So I need a good vertical cloud, like a cumulus-nimbus, or I can do it with a tropical storm, or I can do it with a hurricane. So those are all conditions that can cause lightning strikes to occur. No, I will not get any lightning out of like a cirrus cloud, for example. As far as types of lightning, some of the most common when you see a strike occur is what we call fork lightning, and that's where there seems to be more than one discharge location. So they basically attach to 2 or 3 positive streamers. So when it discharged in more than one stream, allowing the electricity to go to more than one location. This one's a bit deceiving because the truth is this is where the connection was made. These are just those fingers that were stepping down. So this is paths that the electricity tried to take but are dead ends in that sense. Or ribbon lightning. Now, ribbon lightning is when I have one true connection that's made, and it makes one kind of very strong discharge line that comes down. So this is a great example of ribbon lightning. This one's just a pretty example of ribbon lightning, where you can see this was only one connection. And once again, the light that I'm seeing is all after the fact. The connection has already been made. Dry lightning is the term that's given to lightning that is occurring when there is no rain, which is actually pretty common. So don't ever get into the mindset that because there's no rain, there won't be any lightning. That's just not true. And then heat lightning. Heat lightning is pretty much dry lightning, but it's all cloud to cloud. And we call it heat lightning because it's often occurring during our summer months. So it's very, very warm and there's no rain taking place, but we'll see these flashes in the cloud itself. So the cloud will keep lighting up. What's happening is the cloud within the cloud is having lightning strokes occurring within them. There's some interesting lightning forms like ball lightning. St. Elmo's fire, which isn't exactly lightning. It's like static. It's static releases of light energy when small connections are made, when something that is positively charged travels through a negatively charged atmosphere. And then there's sprites, which are large electrical outbursts that tend to happen within the cloud itself. And it kind of shoots off the top of the cloud, so you see it shooting off the top of the cloud. And then blue jets, which is basically the opposite of lightning coming down from the cloud. The blue jet is going up from the cloud. Coming up from the ground. Sorry, I shouldn't have said cloud. Should have said ground. So here's the book's pictures of those lovely things. Now, ball lightning is something that for a very long time we theorized about ball lightning. But it was confirmed back in 2014 and finalized by science that ball lightning is a real thing, and it's actually become more common. With all the electrical items in our homes, If your home, for example, is struck by lightning or in the near area, we often see circuiting occur where it will create a